Warabetri, thank you very much. Okay, it reads as follows. It says, given, okay, is the graph of f of x equals to x cubed minus x squared minus x plus 1, where a and b are the turning points of the graph of f. Okay, so that's basically the equation. I'm going to just copy it down so that we have a clean paper here for us to actually work with it. So the graph of f of x is given to us as x cubed. We're expecting that it's a cubic function, minus, there's an x squared there, and then we've got a minus x, and we also have a plus 1, okay? So we know that the coordinates of a and the coordinates of b will just give us the coordinates of the turning point. The first question says, determine the coordinates of a and b, all right? That's what they're asking us to do. Now, you guys should know that at the turning point, the graph is neither increasing nor decreasing. At the turning point, the graph is stationary, okay? Remember, the gradient of the graph is indicated by its derivative. And at the turning point, the derivative is 0. When the graph is increasing, at this point here, the derivative of the graph is positive. It's greater than 0. It's got a positive gradient because the graph is increasing. Before it comes to this point here, where the graph is going to be decreasing, which is where the derivative is going to have to be less than 0, it needs to stop at some point. That is why at the turning point, the gradient, this is the gradient of the graph, is simply equal to 0. The graph is neither increasing nor decreasing. So when you ask you for the coordinate of the turning point, yours is just to find the derivative and put it equal to 0. Okay, so at the turning point, that's what I'm simply going to do. At the turning point or at the stationary point, we should all know that the gradient of the graph is simply 0. It's not increasing nor decreasing. Now, I need to find the derivative. I think you guys know how to find the derivative. You just multiply the exponent with the coefficient, which means the derivative of x cubed will just simply be 3x squared. The derivative of negative x squared will just be minus 2x. And the derivative of minus x is actually going to be negative 1. The derivative of a constant is always 0. So that's what the derivative looks like. That derivative must be equated to 0. From here, we just need to solve for x. Your factorization will help you a lot in trying to figure out what is going on here. 3x and x is going to give you 3x squared. The multiples of 1, okay, the factors of 1 is 1 times 1. I need to have a minus 2 in the middle. So this product added or subtracted from this product must give me minus 2. When you multiply 1 and x, you're going to get 1x. When you multiply 3 and 1, you're going to get 3x. So the bigger product must take the sign of the middle term. The bigger product is 3x. So that's going to be negative because 2 is negative. So which means this one will have to be positive. That means when I multiply 1 and x, I must get a positive product, so this must be positive. When I multiply 3 and 1, I must get a negative product, so this needs to be negative. Very important for you to keep that in mind. Very, very important. So from what you're looking at using the zero factor law, you can clearly see that we can just simply say, obviously, x is negative 1 over 3, or x is equal to 1. So those are the x values of the turning points. Remember, our cubic looks like this, and it's actually just bouncing on the x-axis here. This is going to be where 1 is. We don't know what the y coordinate is. This is going to be where the other x coordinate is, which is negative 1 over 3. We also don't know the corresponding y value. But as we always tell you, if I know what x's are, it's just a matter of saying I know what x is. Just substitute back to the equation. It will give you what the corresponding y value is. It's always the case. If you know x, the graph knows all its points. So ask it, when x is 1, what is y? Just sub back to the original. Okay. So let's go back to the original. The original was f of x is x cubed. So I'm going to ask, what is f of 1? When you put 1 there, it gives you an answer of 0 because it's going to be 1 cubed minus 1 squared, which is 1 minus 1, minus 1 plus 1, it ends up being 0. So this point is indeed 1 and 0. Now we also want to know what is f of negative 1 over 3. So we have to substitute this back into the original equation. So I'm going to call a calculator to come and do the assistance in this case. So you're going to open your bracket. You've got negative 1 over 3, okay? Then you close the bracket, you put this to the power of something exciting, which is 3 in this case, all right? Then you're going to say minus, open bracket. There's another negative 1 over 3, okay? And then you have to close the bracket. This time, you have to raise it to the power of 2. Remember to do the subtraction again for the next one, which is negative 1 over 3, close bracket. So basically what is going on here, we're just trying to substitute back this x value of negative 1 over 3 to try and figure out when x is negative 1 over 3, what is y. So the calculator says this is going to be 32 over 27, which is just 1.19 if you round off to 2 decimal places. I'm going to keep the fraction version because I don't need to draw it. So I'm going to take 32 divided by 27, okay? So the y value is going to be 32 divided by 27. So there's my corresponding y value, 32 over 27. So these, remember the question was asking for the coordinates of A and the coordinates of B. So answer questions grade 12. So A will be negative 1 over 3 and 32 over 27, and B will just be 1 is to 0. That's what these things are going to be, because this is where A is and this is where B is located. All right. The next question says to us here, we need to determine the turning point of G if G of x equals to f of x minus 2. Very interesting. So now let's ask ourselves, what is going on here? What is actually happening here? So what is going on is, if you're asking me to find the coordinates of the turning point of G, and you're telling me that G is f of x minus 2, what exactly did you do to f in order to get G? So you guys should know that this is a shift along the x-axis. The graph of f was translated, okay? How many units? 2 units. Now, question is where? Up, down, left, or right? If you're going to have x minus 2 like this, it means it was moved 2 units, not to the left, but to the right. If it's a minus, it moves right. But if it was a plus, it would move left. So this graph has been moved 2 units to the right. Now, if you look at the graph of f, the one that you're dealing with, the one we've got in the drawing, and you move it 2 units to the right, you just shift it 2 units to the right, okay? Then you're going to get the new graph, which means at point B, I said there's a 1 here. You move that 2 units to the right. It means it's going to move from where it is. It will move 2 units, not at 2, but it's going to come and sit at 3, which means you'll now be looking at something that looks like this. It's going to bounce here now, okay? And then obviously it's going to be doing something else there. So the graph has been moved to the right. How many times? Twice. That means the coordinates of the turning points are also going to move to the right twice. Everything is moving right 2 units. So if you want the coordinates of the turning point of G, I'm going to get those ones that I have from the graph of f and say, for number 2, the turning point coordinate of G is going to be on the first x value. Don't subtract, add 2. We are moving 2 units to the right. But the y coordinates do not change. They remain the same. We did not move up and down. The second turning point was supposed to be at 1 and 0, but once more we are moving that 2 units to the right, and the y coordinates are not changing because of the fact that we're not moving up or down. So you guys need to just think about the fact that negative 1 over 3 must be added with the number 2. So what is negative 1 over 3? A third. And then you want to add 2 on that. What do you end up with? You end up with 5 over 3. Okay, so that's what I'm going to have here. 5 over 3 and 32 over 27. And then the next turning point is going to be 3 is to 0. So very simple question, but the concept behind what is going on is very, very important. Let's go to the third one. So the third question that you have here is asking for something awesome. They say now determine the rate of change from A and B. Okay, the rate of change from A and B, which means the rate of change we're just discussing the concept of the gradient, guys. Very important for you to try and figure it out. So we want to find the rate of change from A and B, okay? So that means we just want the gradient from A and B. So the rate equals, right? Change in y over change in x. Change in y over change in x. So if you just try and figure that out, you've got the point at A, which is simply that point, negative 1 over 3 and 32 over 27, and B, which is 1 and 0. So y2 minus y1. So y2 minus y1, okay, divided by x2 minus x1. Very simple. Rate of change, we're asking we're asking for the gradient, right, between A and B. At A, the gradient is 0 because it's the turning point. At B, the gradient is also 0 because it's the turning point. But from A to B, we're trying to figure out what the gradient of the graph is, the average rate of change. At what rate is the graph changing from A to B? So I'm going to call the calculator again to try and do a quick computation of what's happening here. We've got a fraction, so y2 minus, there's my y1 there, which is going to be 32 divided by 27. We're sharing a concept. The important thing is not really the numbers, but it's the idea. How do you work with this? What are we asking you to figure out? How do you find the solution? Rate of change is gradient. At what rate is the graph changing from one point to the other point? Okay, the average rate of change. So if you actually have what you're looking at now, you end up with an answer of -8/9. So that's what I'm going to actually have as my final answer, -8/9. Awesome question. All right, so we're going to go to the next one. What's the next question asking? These questions are very nice. They don't change in terms of the concept, but the numbers are going to change all the time. So what we are trying to do here is just to give you ideas of how do you work with this if you are asked to do whatever is being asked to the present moment. Check the next question, for example. So the next question says to us, we need to determine the equation of the tangent at x equals half. Where does the tangent cut the x-axis? So let's discuss the analysis of that. First of all, we're asking for the equation of the tangent, okay? So what do we know about the tangent? Well, we should know that a tangent touches the graph at one point, okay? So I don't need all these guys. Please allow me to remove them so we can look at half. Where is half likely to be? Well, remember, 1 is here at B. That's where 1 is. So half is somewhere here. We want to find the equation of the tangent, right? Determine the equation of the tangent. A tangent is a line that is going to touch the graph at one point, at that point there, when x is half. So it's a straight line. How do you find the equation of a straight line? Well, you need two things to find the equation of a straight line. You need a gradient of that line, and you also need a point that the line is passing through so that you can use your y is mx plus c. That's it. If you've got this idea in your mind, you can find any equation of a straight line. Now, the questions that we have to ask ourselves, where are we going to get the point? Where are we going to get our gradient? And how are we going to finish off this question as you're looking for the gradient, for the equation of the tangent? The ideas don't change, they're the same. What was given to us was half. So you were told that x is half there. We need to find the corresponding y value. What did we agree on? The graph knows all its points. If x is half, how do you find the corresponding y value? Just take the half and substitute back to the equation. You start noticing that the concepts keep repeating all the time. Okay, so let's go back to that. So I want to know when x is half, what is y? So we're going to call back the graph, the calculator, to assist us on that. So we'll ask by substituting half everywhere where we see x. Okay, half is 0.5. So there's 1/2, right? Close bracket. It must be cubed. So 1/2 cubed. Right, and then we're going to have what? Minus, because the equation says minus x squared. So minus, my x is a half, so minus a half. Okay, this has to be raised to the power of 2. And then we have to add a 1. No, subtract the 1 first. Minus 1/2, we have to minus this one before we even get to the 1 that we have at the end. So that's x cubed minus x squared minus x, all right? At the end, we need to add a 1. What do you end up with? 3/8. Very exciting. So where x is half, the y value comes out as exactly 3/8. I've got my point. What's missing? The gradient. Now in grade 11, we were dealing with what we call average gradient. We now want the gradient at one point. How do you find the gradient at one point? It is always equal to the derivative at that x value of interest. So I'm going to go back now to the next page so that we can have space to compute this particular situation here. That's going to be the D question. So f of x was given to us as exactly x cubed, all right, minus x squared, and this has to subtract x, and we're going to add 1. We are looking for the gradient function. This is the gradient, the derivative. It says 3x squared minus 2x minus 1, okay? So we are looking at the gradient. We want the gradient when x is half, okay? That's where your gradient always comes from, and it doesn't change. Always the case. So now I'm going to just find what this is equal to. Then I'll be sitting with my beautiful gradient, which I can then use to try and find what the equation is going to eventually be. So 3 times 1 over 2, okay, we want the gradient when x is a half. That is square minus 2 times, okay, 1 over 2, right? And then you close the bracket there. You'll see we're just substituting x of half to find the gradient. And then we need a minus 1 at the end. And this amounts to negative 1 1/4, which is negative 5 over 4. So there's your negative 5 over 4 as your m. And we just found out that the point is half and 3 over 8, which means we just made like math here. So we can just finish this off, and then we've got the equation that you're looking for. So y is mx plus c, very simple stuff. Y is 3 over 8. M is negative 5 over 4, x is a half. We are looking for c here. We can then do the multiplication. So 3 over 8 is negative 5 over 8 plus c. Then you take this one to the left-hand side. You get 3 over 8 plus 5 over 8 is c. That's 8 over 8, which is c value of 1, which then, if everything is still okay, remember we are looking for the equation of that particular tangent, which will certainly pass at x is 1, and it's got a point half and 3 over 8. So everything is still fine up to so far. Okay, therefore the equation is going to be y equals to negative 5 over 4 x plus 1. They're asking where is it passing on the x-axis. That's what was part of the question. Where does this cut the x-axis? They are looking for the x-intercept. That happens when y is 0. So you can just put 0 here. You've got negative 5 over 4x added with 1, which you can then simplify by just changing this to 5 over 4x plus 4 over 4. 1 is the same as 4 over 4, beautiful people. I'm going to multiply everything by 4 because I hate that I've got fractions going on here. So 0 is negative 5x when you multiply everything by 4 plus 4. And then you're going to have 5x is 4 when you add 5x on both sides. So this is going to cut the x-axis when x is equal to 4 divided by 5. Awesome. Not difficult, very straight to the point. As long as you've got an understanding of what is going on when we start asking you questions, particularly questions around ideas that involve gradients, tangents, x-intercept, y-intercept, and those kinds of things, this becomes very, very simple. You don't have to struggle when you're working with this. The last question is asking us to determine the point of inflection. Point of inflection is where the graph changes concavity. Remember, a cubic graph has got 2 turning points. It starts by being concave down, and then it's going to be concave up at some point. There's a point where it changes its concavity. That is known as a point of inflection. Right. So how do you find the point of inflection? Let's go back and check what is going on. Remember, our cubic looks like this. All right. So there's a point where this is concave down, and there's a point where the graph is concave up. Okay. So that point is the point of inflection. That is what we are interested in finding. There's many ways of finding that, right? I can actually do that in 7 different forms, but I'm not going to do that. So what I'm simply going to do is work with the popular one, which says the second derivative must be equated to 0 if you're looking for the point of inflection. You derive the graph twice, or the function twice. So let's find that. F of x was given to us as x cubed minus x squared minus x plus 1. Let's have fun. First derivative, what do you get? You get 3x squared minus 2x minus 1. Second derivative, oh, this is awesome. You're going to get 6x minus 2. That second derivative must be equated to what? To 0, because at the point of inflection, the second derivative of the graph is 0. That's where it changes concavity. So negative 6x is negative 2, so x comes out as 1 over 3. They just said we need to find a point of inflection once more. A point has got an x coordinate and a y coordinate. If I've got x, how do I find y? Somebody just said it. You've been doing the same thing over and over again. Just substitute this 1 over 3 back to the original equation and see what the y value is going to be. So wherever I see x, I'll just take and plug this 1 over 3 here. Everywhere you see x, you're just going to go plug it there and try to find what the corresponding y value is. So we are interested in f of 1 over 3. So f of 1 over 3 is what we want to find. What you get when you put x as 1 over 3. So let's go back and try and see what that is going to look like. Okay, x is 1 over 3. And then you need to close a bracket there. You've got a cube. Remember, this has to be x cubed, right? Then they said minus x squared. But my x is 1 over 3, right? Then close bracket. There's a square there. Minus another one here, which is 1 over 3, right? And then you're going to have the last plus 1 at the end, and then this just gives you an awesome answer of 16 divided by 27. Okay, there's your 16 over 27. There's many ways of actually finding the point of inflection. Just for education purposes, we can also tell you that the x-coordinate of the point of inflection is given by a negative b divided by 3a, which is where, basically, from the cubic, your a is a 1 here, your b is negative 1, your c is negative 1, and the d value is 1. So when I sub the b value and 3 times the a value, it is supposed to give me the x-coordinate of the point of inflection. Just to confirm that it does indeed, my b is negative 1, so I'm going to have negative 1 divided by 3 times my a value is again a 1. Negative times negative gives you positive. 3 times 1 amounts to 3, which confirms that x value of the point of inflection that we found right there at the bottom. There's your 1 over 3 right at the bottom of our yellow calculation. So basically, this is what we end up with. Very awesome indeed. I hope it actually helps you to understand what is going on. These ideas don't change. They're the same all the time. If you just remember them and you are able to apply them, you will never go wrong at all. It's always easy, and you can get answers without any challenges if you're going to work with these particular ideas. So there's another question here that we are also going to try and look at based on these questions that you guys sent to us. So let's go and see how it looks. Let's go and see how that particular question looks. We'll take the one at the end, which is number 3. It says to us here, the radius of the base of a solid is x millimeters, while the height is 250 minus x millimeters. We now need to show the volume of the cylinder is given by 250 pi x squared minus pi x cubed. Now, this question is not even related to differential calculus. This is a pure measurements question, right? Volume. Do you know how to find the expression for volume? Okay, that's basically what the story is in this particular case. So let's see what will happen if we try to do that. Well, the universal formula for volume in this case is going to be the area of the base multiplied by the perpendicular height. The base here is the circle, all right? This is basically what my base is going to be. Now, the area of a circle is pi r squared. But that needs to be multiplied with the height. So I'm going to just take the height like that. This is actually a cylinder just lying down. If I put it upright, it would look like this. That would be my height. And the base will just simply be a circle, which you can also get from this. So that means that 250 minus x is actually the height of this particular cylinder that you're looking at right now, which means we can have 250 minus x right there. But what is the radius of this particular thing? We were told that this is actually containing, right, the base, the radius of the base. It was given in the love letter, the opening statement. The radius is x millimeters. So my r is going to be x. What am I looking at now? I'm looking at pi x squared times 250 minus x, which when you multiply, you're going to get 250 pi x squared minus pi x to the power of 3. That's actually what we end up with as the solution to this, which is exactly what we were required to do. Remember, they said show that the volume of the cylinder is given by 250 pi x squared minus pi x cubed. Now, the last part here says we need to find the volume. Like it says to us, find the volume of x, I think it was supposed to say value. It says volume here. Find the value. It was supposed to say value of x, which results in a maximum, not the volume of x. X doesn't have a volume. They wanted the value of x, which results in maximum volume. So for maximum volume, just know that the derivative is going to be equated to 0. So for maximum volume, okay, v prime of x must be equated to 0. So derive equated derivative to 0 and just solve for x. Okay, what's the derivative of what you're looking at? Just multiply the exponent to the coefficient. We're going to get 500. 250 double is 500 pi x minus 3 pi x squared. When you multiply, that must be equated to 0. And then you just simply solve for x. Okay, x into 500 pi minus 3 pi x is 0. That means x is 0, or 500 pi minus 3 pi x is 0, which then, if you just simplify here, you'll end up with an x value of exactly 500 pi divided by 3 pi, which you guys can simplify because pi's will cancel, so it's just simply going to be 500, okay, divided by 3. So let's go 500 divided by 3, you get an answer of exactly 166.67 if you round it off to do decimal places. So that's basically what is just going to happen, and that will be the answer to this, obviously in millimeters. All right.